when solving problems like these, we're trying to figure out a linear equation that relates the monthly charge C in dollars to the number X of kilowatt hours used in a month. So we're given some information up here, and by the way, this should say of. So we have a monthly charge of $11.47. So we're being charged that flat rate, so we can put that in right now. So the monthly charge C is equal to 11.47 plus something. It says plus 11 cents per kilowatt hour, up to 600 kilowatt hours. And so it gives us a range for a domain for the values of X, the number of kilowatt hours are going to be charged for. So that being said, the main thing to identify here is that we're being charged 11 cents per kilowatt hour used. And then, so what does that mean? We could just put 11 right there, and the answer is no. You don't want to just write 11 there because you already wrote a number out here, and this number is represented in dollars. So you can't just combine a dollar number with a number of cents number. You have to make sure all your numbers are either in dollars or cents. So I was going to say it makes sense to put them in dollars. So we want to do that. We want to convert 11 cents to a number of dollars, and you can, maybe you know already that's 0.11, but I'll show you just in case you're wondering how to convert cents to dollars, or you can convert cents to anything as long as you can multiply by 1. But cents to dollars, if we multiply 11 by 1, and that would be in the form of $1 over 100 cents. So if we multiply 11 cents by 1 over 100, or $1 over 100 cents, what's going to happen is the cents are going to cancel, and this is just a way to do any conversions. So you have 11 over 1 times 1 over 100, that's 11 over $100. Well, anytime you anytime you divide by 100, you're going to move the decimal over 2 to the left. So what we really have here is 11 over 100, which can be written as 0.11 dollars, and maybe we already knew that anyway. So anyway, now that we have this number of cents written as a number of dollars, we can write that as 0.11, and 0.11 times X. X represents the number of kilowatt hours used, and that would be our total charge for that 1 month for the electricity from Huntington Beach. So if we graph that, what we want to do here is figure out, okay, well, X represents, write it like this. Let's move it up a little bit there. X is going to represent the number of kilowatt hours used, and then the C is going to be the charge, and that's going to be charge in dollars. Okay, so it's 11.47, so we have to figure out a good unit of measure for the vertical axis, and the amount of money is going to go up. So let's maybe go 5, 10, 15, 20, maybe we do something like that, or maybe this is 10, maybe 10 just by tens. We just have to pick something that so it's the unit of measure is consistent, and then X representing the number of kilowatt hours. Well, X is going to go for is the lowest that X can be is 0, and the highest that X can be is 600. So let's put 600 out here, and if we cut that in half, that's 300. So we have 1, 2, 3, 4, 500. So we can easily make this a little bit different if we want, but the bottom line is it's going to look something like that, where it's not super important that you get exactly 11.47. You can estimate this. The main thing is we're estimating right now. 11.47 plus 0.11x. Well, that's going to be going up pretty slowly. And 0.11x, so that's the slope, 0.11. You go up 0.11 and over 1, up 0.11 over 1. So think about it. If you think about it, 100, you're going to go up 11 and over 100. So maybe we think about it that way, because we can, up 0.11, that's tough to see, and over 1, that's even tougher to see, because this, the distance between 0, the vertical axis, and this first little tick mark on the horizontal axis, well, that's 100. So again, we can go up, think about the slope of this line. This is in slope-intercept form, 0.11 or 11 over 100. If we go up 11, so we're already at about 11. Go up 11, we're at 22 over 100. So something like that. And then, so there's another point there, and then we go up 11 more, or a little bit more than 11. So maybe now we're at like 11 more than that, or almost 12. So we'll be somewhere up. Oops, I didn't mean to write that. And then we're going to go over 100. So something along those lines right there, no pun intended. And then we're going to draw a line that's going to be somewhere up in the neighborhood of there. So that's supposed to be a straight line. That's graphing the equation. And that's about it. So we can write the equation of that line, 0.11x plus 11.47. So that's the equation of that line, and again, it has a limited domain. The next question is, what is the monthly charge for 200 kilowatt hours, or using 200 kilowatt hours? Well, all we have to do is figure out what the charge is when we replace x with 200, and when we do that, we just put it into, oops, I meant to put a 200 right there, so we put a 200 in place of x. And when we calculate that, 200 times x is 200 times 0.11. That's 2 times 11 is 22. And but we have 2 more zeros there, so it's 22. So 2 times 11 is 22. 200 times 0.11 is 22. And then we add to that 11.47, so we get 33.47. That would be dollars. Okay. Now, in monthly charge for using 500 kilowatt hours, well, that's the charge when x is equal to 500. And let me do this right this time. We have 0.11, multiply that by 500, and we're going to add 11.47. That's the monthly charge, regardless of how many kilowatt hours we use. So 5 times 11 is 55. 500 times 0.11 is 55. And then we have plus 11.47, and we get $66.47.